I am visible and my screen is also visible and I am audible. Somebody please confirm. Okay, so let's
Yes, sir.
start. Let's start. So these live interactions are for weekly assignment practice and live interactions, and also during this sessions that I will be conducting on every Friday from 6 to 8 p.m. I will be discussing the assignment problems, not the problem that have been given to you in this course run, but the previous course run they were having some assignment problems. So I will be discussing those, and I will be talking about how to approach those problems, and what all concepts you need, what all concepts are there that you have to clear when you are appearing for any entrance exam or in your semester exam or in this course exam. So this there is one more information that I want to tell you. Apart from the this course assignment practice for this session, I am also talking about the GATE Excel 2023, which is going to happen on 11th of Feb. And in the for this, I will be giving you the important topics in chemistry and biochemistry, because in Excel subjects, the two compulsory in Excel domain of GATE examination, the two papers that are compulsory are chemistry and biochemistry. Other than that, you can select any of the subject such as botany, zoology, or anything. So, but the chemistry and biochemistry lies in this particular subject NPTEL course. So that is why I am taking that in this particular session. So, and other than that, first I will be talking about what is the course introduction, what is this course about, then what are these live sessions, and a brief about myself. Then basic concepts in biochemistry, and then revision with mnemonic techniques to remember whatever ma'am has taught in week one course, like different amino acids, their category, and how to remember those using some mnemonic technique that I will be giving you in this session. Then scope of this topic with research perspective, that also I will be telling you, so that you will have uh, kind of gesture how to take this subject furthermore in your future aspiration. Like if you are aspiring to become a researcher, or you want to pursue a higher studies, MTech, PhD, and way more. So let's now talk about. Let's now give a brief introduction about me. I am Karan Kumar, Senior PMRF Research Fellow at IIT Guwahati, and then I am enrolled in School of Energy Science and Engineering. This is my email ID, the most important information. You can email me at karan18@itg.ac.in regarding any doubts, not only related to this course, but also if you have any doubts in your related to your career or higher studies, you can always reach me at this email ID. More information about me can be retrieved from my website, which is www.itg.ac.in/stud/current18. Then I have completed my bachelor's from in biotechnology from NIT Calicut in 2018. And these are my other social media handles: LinkedIn, ResearchGate, Google Scholar, and my YouTube channel that you can follow by, because I will be recording all the sessions, all the interactive sessions, and that I will be uploading in that YouTube channel. You can refer that later on. If somebody have missed a particular session, they can refer there. The other NPTEL PMRF-TA are Siva from IISER Bhopal and Mohan from IISER Bhopal. They will be taking the sessions on every Sunday and every Tuesday. And meet link will be also given in the discussion forum of your course. There also you can find, or else I will be uploading this PPT, the PDF of this PPT, on the drive folder, and will be sharing with you with all of you. What is this NPTEL course? NPTEL course, you all are enrolled. If somebody has not enrolled and joined from my LinkedIn account, for them, the introduction of this course is that this is a biochemistry course, which is taken by the Professor Swagata Gupta from Department of Chemistry, IIT Kharagpur. I am from IIT Guwahati, and the course link is attached in this hyperlink. You can click on this link and then you can navigate to the course and register, because the registration is still going on. You can join it if you have not joined yet. What are the PMRF-TA live sessions? These are the weekly live doubt clearing sessions. If like let us say you have gone through the weekly lectures, and then in 1 week lecture there will be some assignments given to you which you have to submit within a due date. So if you are not able to solve, then these sessions NPTEL team has conducted because to clear those doubt, and how to approach those problems, that will be discussed like in supplementary to the regular lecture that you will be uh, attending in the regular course. Then this is a part of annual PMRF deliverable. For more information of what is PMRF or Prime Minister Scholarship, you can go to the website PMRF.in. Okay. Then all recorded sessions will be uploaded on the YouTube course YouTube channel. Then career guidance comes. This NPTEL live sessions are also started because to give the career guidance and to solve your like problems and to generate a scientific thinking within you, so that you, if somebody is interested in pursuing the higher studies, they can go ahead. So I will be taking every Friday, and the first is the 3rd February today, and that session will be conducted from 6 to 8 p.m. PPTs and resource material will be made available after the end of every lecture. The concepts covered in week 1. Yes.
सर मेरे
Please.
डाउट
Yes, yes.
सर मेरे डाउट था कि वो एक एक्स्ट्रा पॉइंट मिलता है ना, क्रेडिट, एक एक्स्ट्रा क्रेडिट, वो कब कैसे मिलता है?
That I think you need to contact NPTEL team, or else I will let you know. Once I contact the NPTEL team at IIT Madras, then I will let you know. That is particularly like out of scope of this, but I will try to get into it. I will help you in that. Okay. So I hope you whoever have joined, they must have gone through the week 1 lecture, and the concepts that were covered in the week 1. Uh, those were very basic. The name and structure of amino acids, 1 letter and 3 letter code, isoelectric point, and effect of side chain residue on isoelectric point. Then important property of amino acid like size, charge, polarity, hydrophobicity, and aromaticity, peptide bond formation, primary, secondary, and tertiary alcohol structure of protein, and then interaction of different forces within the protein for stabilization. Now you have gone through the lectures, so let me give you a few questions, very basic question, and try to answer these. So which of the following sets, if you are not able to answer, no problem, I will tell you how to approach, and then I will also give some techniques, mnemonic techniques to remember these and classify the amino acids. So, but try to like give answer to these questions. The first question is, which of the following sets contain all aromatic amino acid residue? Option A, G, D, and E, F, Y, W, R, K, H, and I, V, L, M. For solving this, you need to know the what are the 1 letter code for amino acid, what are 3 letter code for amino acid, what the different amino acid side chain are. So those who are aware, they may answer, and then I will discuss.
Option B.
Option B, FYW. F stands for?
Phenylalanine.
Y stands for?
Tyrosine.
And W stands for?
Tryptophan.
Very good. Answer is very much correct. Option B is correct. Then identify the amino acids containing non-polar aliphatic R groups. Option R, glycine, alanine, leucine, phenyl, alanine, tyrosine, tryptophan, lysine, arginine, histidine, and serine, threonine, cysteine. What is your answer?
Option A.
Option A. Identify the amino acids containing non-polar aliphatic R groups. What is your option?
Yes, sir.
Option A, one pole. Then any other option? Okay, your answer is correct. Glycine, alanine, and leucine. Glycine is the simplest amino acid which have the achiral carbon. Okay, and other properties that I will be discussing in the subsequent slides. Of your question number 3 is the two amino acids having R groups with a negative net charge at pH 7 are options cysteine and methionine, option B arginine and histidine, option C aspartic acid and glutamic acid, option D proline and valine. Option? Yes.
C.
Option C. Any other option? Anyone? Can you tell me why
Sir,
option C
C.
is correct? Can you tell me why option C is correct? Why they
Sir,
are
because
negative charge? Yes.
sir, because they are acidic amino acids.
Acidic amino acid. Very good. And what is the property of acidic amino acid? And why they will hold negative charge? They are acidic amino acid. That is very much correct. Yes.
Yes, sir.
So their pK value is less than 7.
Yes. Very good. The R groups that they are containing, their pK values are less than pH 7. That is why they will be holding a negative charge at pH 7. Very good. So question number 4, which among the following has or have the most chiral center? Your state, like this is a kind of a question which you have the 4 different options, and then out of those you have to select the correct answer. One isoleucine, serine, tryptophan, and threonine. Options are 1 and 3 are correct. Option B only 1. Option C 1 and 2. Option D 1 and 4. Which have or has the most chiral center?
Sir, option fourth.
Option fourth. Okay, option fourth means first and fourth.
Yes,
Isoleucine and threonine. Right?
yes, sir. Yes, sir.
Yes. Yes. Very good. This is the correct answer. Now, 4 more questions, and then I will be talking about the different mnemonic technique to remember those who are not able to answer. They will be able to answer after that mnemonic technique. So your 5th question is choose the correct statement. Tryptophan and tyrosine are more polar than phenylalanine. Option B, leucine is commonly used as an ingredient in the buffer of HDS page. Option C, aspartate is a beta branched amino acid. Option D, lysine is a basic amino acid with an imidazole group as a side chain. What is the correct statement among these 4? Any guess?
Sir, option A.
Option A. Okay. Any other options? Very good. Option A is correct. Tryptophan and tyrosine are more polar than phenylalanine. And why is it? Can you justify?
So for tyrosine, I know that it has an OH group, so that
Yes.
makes it more polar than phenylalanine.
And what about tryptophan?
It contains carbon and hydrogen.
That makes tryptophan, if it only contains the carbon and like carbon and hydrogen, then this will be also similar to phenylalanine. What is the difference between tryptophan and phenylalanine then? Why tryptophan is more polar than the phenylalanine?
Sir, because it has more aromaticity.
Aromaticity, okay. And
It contains two benzene ring, and phenylalanine contain only one benzene ring.
yeah, that is a kind of a good analogy. But the crypto, because of the conjugation, because the more ring, it has more conjugate, like electron delocalization. Because of that, it is little bit more polar than the phenylalanine, because electron is mostly delocalized among the ring, and that makes it more polar than the phenylalanine. Okay, very good. So option A is correct. Now, which among the following is a amino acid? Histidine, proline, glycine, serine.
Sir, option B.
Option B, very good. Yeah, proline. We will be discussing more about the proline in the next subsequent slides. So which of the following is not a sensible group of amino acid based on their polar properties? Okay, not sensible grouping based on their polar properties. Okay, now options are alanine, leucine, valine. Option B, phenylalanine, tryptophan, tyrosine. Option C, aspartic acid, isoleucine, and proline. Option D, asparagine, serine, and threonine.
So
What
option
is the correct
C.
option? Option C.
Option A.
Yeah, because isoleucine is not a polar, right? It does not contain a polar side chain. It is more of a hydrophobic chain, right? That we will discuss later. Now, check the correct one-letter code for asparagine, tyrosine, and lysine. Which is the correct option?
Yes, sir.
Which one?
Option A.
Option A. Very good. NYK. Asparagine stands for N stands for asparagine. For tyrosine, that is Y. For lysine, that is K. Very good. Now let's come to the important thing, tricks to remember all this. Those who were not able to like remember it or answer the previous questions, they can remember using this technique. The first trick is to remember non-polar hydrophobic aliphatic side chains. Okay. Now why we are only stressing on the side chains? Why? Because in amino acids, let's discuss a few important. Uh, Let me give a new slide. Okay. Yeah. Let's discuss a few basic thing about amino acid that you might have like kind of introduced during the lectures. The common things in amino acids are amino terminal. They have amino group NH2. They have carboxylic group. They have hydrogen, and the only difference is R group, right? So to identify a peptide chain, these three things will be common to all kind of amino acids. Whatever amino acid all 20 type of amino acids, these three will be common. So this information is kind of a redundant information, right? To track about, right? The important thing that is changing in all amino acids are different amino acids are their side chain, which is represented by R. Now, now if all amino acids have these three things common, then their properties will not vary because of these three. They will only vary because of side chain. So that is why whenever we talk about the properties, or whenever we talk about their like if we are calculating their pK value, pK value, or their their at physiological pH, what will be their charge or something. So that because of R group, they vary a lot among themselves, right? So that is why we need to study what are the different R groups, what are the different side chains available in the particular and the different type of amino acids. So that is why we mostly focus on the properties is defined by their side chain. The side chain also tells about where this particular amino acid locate, whether they will be in the surface, whether they will be in the kind of like inside the protein, like in the compact form, or where like what will be their size, what will be their different property, like at different pH, what will be their charge. So these all things are depending on their particular side chain. So to remember the non-polar hydrophobic aliphatic side chains, those to remember those, you can remember a trick which is a phobia of a vamp girl. Phobia of a vamp girl, as it suggests, you can remember that as a girl which have the phobia of a vamp girl. Okay, phobia represents hydrophobic. Then this technique is to remember the non-polar hydrophobic aliphatic side chains. Okay, so here V represents valine, A represents alanine, M represents methionine, P represents proline. Then in girl, G represents glycine, I represents isoleucine, and L represents leucine. So now you can check all the side chains. Now tell me which will be the alpha carbon in all amino acids. Whether this is alpha carbon, this let me locate it for this one. This is 1, 2, 3, 4. Which one is which marking is the alpha carbon?
So carbon number 3.
Carbon number 3. Very good. Because the alpha carbon will be that carbon around which all 4 groups or atoms attached with that will be the different. So here if we check at this carbon, one group is attached which is amine group, then carboxylic group, another is this branched chain, and one is hydrogen. Hydrogen is not represented here. Okay, so carbon 3 will be alpha carbon. Similarly, here the carbon will be alpha carbon. Then in this, the alpha carbon will be this one. In this, the alpha carbon will be this one. In this, alpha carbon will be this one. Then in this, the alpha carbon will be this one, which is glycine, and here the alpha carbon will be this one. Now why it is proline? Why proline is called amino group? Because here you don't find a complete amino group, and it is a kind of imine. Okay, and because the side chain makes it as a complete circle, it branches with like it makes a complete kind of a ring structure with the amino group, and this amino group is presented in a imine group. So that is why it is called as a amino acid, not amino acid. Okay, so proline and glycine makes a different uh, grouping itself in all amino acids. So remember that why glycine is represented as different. Why? Because glycine does not have a chiral carbon. The R group is also a H. So apart from that, because of the R group is also H, the 4 atoms attached to it are not different. So that is why these are this makes this carbon as a chiral carbon, and glycine is not chiral. Okay. So now the next thing in this, if you leave the common things, redundant information, which is carboxylic group and amino group in all amino acids, if you see in side chain, they have only carbon and hydrogen. Okay, only leaving methionine, because methionine has sulfur atoms in its side chain. Okay, apart from that, all the side chains have only carbon and hydrogen. Because of that, it makes them hydrophobic. Okay, for making like if you are studying a kind of amino acid, and either it be it amino acid or any compound, if they are hydrophilic, then they should make a hydrogen bonding with water molecule. Because of that only we say hydrophilic. Hydrophilic means water loving. So if certain compound is water loving, that means it should have a polar nature, or it should make hydrogen bonding with the hydrogen atom, like with the water molecule. Okay, but because the side chain only contain carbon and hydrogen, so these are the hydrophobic side chains. And these only contain carbon and hydrogen, so they are aliphatic side chain, right? And non-polar because they do not have the electronegativity difference, right? So to remember these non-polar amino acids, non-polar hydrophobic aliphatic side chain amino acid, you can remember them by fovea of a Wemkel, where V represents valine, A represents alanine, M represents methionine, P represents proline, G represents glycine, I represents isoleucine, and L represents leucine. Another non-polar amino acids are the aromatic side chain containing amino acids, which are phenylalanine, tryptophan, and tyrosine. Here, tyrosine also have hydroxyl group in attached to the this benzene ring. So because of that, it has more kind of a more nature of polarity than these two. Okay, here is a tryptophan which has higher conjugation than the phenylalanine, and also it have a this heteroatoms in its side chain. Because of this heteroatom, the carbon nitrogen difference, electronegative difference, it makes more polar than the phenylalanine. Understood? So to remember the non-polar hydrophobic aromatic side chain, you can remember them by aroma of pine and timber tree. You can imagine there is a aroma. Aroma means a kind of smell. So aroma of pine, you are lost in a forest where pine tree and timber tree are there, and you sense the smell of it. So by this you can remember non-polar hydrophobic aromatic side chain, where P represents phenylalanine, T letter represents tryptophan, and another T represents tyrosine. Okay, so and to remember the different side chains, you should have this like you must remember these side chains because many properties will depend on the side chain. So try to remember and kind of have this in your brain. Now the next thing that we will discuss is to remember the polar. Now we have already discussed the non-polar side chains. Now to polar, neutral, and hydrophilic side chains. So hydrophilic means they will have the tendency to make hydrogen bonding with water, right? So that you can remember using come take gas. Okay, come take gas. You can imagine them as a there is a kind of gas station and that is calling you come and refill your gas. So come take gas. So here in C in come represents cysteine, which has the SH side chain, which in their side chain have the SH group. Then T in take represents threonine. Threonine have OH in its side chain, hydroxyl group, which makes the hydrogen bonding with water and make them the hydrophilic. SH also can make the hydrogen bonding. So because of which it is hydrophilic. Now in gas, G represents glutamine, A represents asparagine, and S represents serine. Right. So you can remember threonine has OH group, which is branched at which carbon? This if this is alpha, then this will be the beta carbon. At beta carbon, you have OH group. In cysteine, at beta carbon, you have SH group. Then glutamine, it has this amide group. And similarly in asparagine, also you have amide group, right? CONH2. In serine, you have OH group at beta carbon. Okay. So to remember polar, neutral, hydrophilic side chains, you can recall them using the technique come take gas, where C represents cysteine, T represents threonine, G represents glutamine, A represents asparagine, S represents serine. Now to remember the amide containing group that already I have discussed in this chain, you can use the two technique. One technique is glue contain acid. So glue contain acid represents the amide containing side chains, which is glutamine and asparagine. Then hydrophilic negatively charged acidic chain, that also you can remember by glue contain acid. Okay, where G represents glutamate or glutamic acid, A represents aspartate or aspartic acid. You need not to remember these two using the this kind of trick, because these are the very simplest thing to remember. But if you are kept forgetting, then you can remember using, then you can use this trick. Glue contain acid, which talks about the amide containing side chain, and hydrophilic negatively charged acidic chain. Okay. Another technique is to remember the alcohol containing group, which is alcohol taste sour, where T represents the threonine, S represents the serine. Okay. Another technique to remember the sulfur containing group, which is supply chain management, where C represents cysteine and M represents methionine. Okay. Next technique to remember the hydrophilic positively charged or basic side chain. Okay. That you can remember by the message, which is Last Action Hero movie that you have watched. So in Last Action Hero, L represents lysine, A represents arginine, H represents histidine. Okay, and you can follow the side chain here. The side chain for lysine is this one. Lysine has NH2 in their side chain. Arginine has guanidine group. Okay, methionine has this SH3 S in their side chain, and cysteine has SH group, which can form the hydrogen bonding. Histidine is a very interesting amino acid. The thing why it is important, that we will be discussing when we will be discussing about their pK values and how to calculate the pK for a complete side chain or complete given like short peptide bond. If short peptide chain is given, then if you want to calculate what is the pK value of it, that also we can discuss in the upcoming slides. So the next thing to remember, because there will be a question in all kind of comprehensive competitive examinations or your semester examination also in biochemistry textbook, you will be asked to identify the essential amino acid. So there are a total of 10 essential amino acids and 10 non-essential amino acids. Can somebody tell me what are essential amino acids and what are non-essential amino acids? Anyone?
Sir, essential acids are produced in body itself, sir.
Essential.
No, non-essential. Essential acids we have to take from our diet, sir.
Yes, very good. So essential, to remember those essential amino acid, you can recall that using a private timber hall. Private can be sorted abbreviated as PVT, timber, tim, and hall. So you can imagine you are going to a timber hall, which is private company, private owned. So here in PVT, P represents phenylalanine, V represents valine, T represents threonine. Okay. In TIM, T represents tryptophan, I represents isoleucine, M represents methionine, H represents histidine, A represents arginine, L represents leucine, and another L represents lysine. Okay. So thereby these are the 10 amino acids which our body cannot produce and that need to be taken by the diets. Okay, so the important thing that I have briefed here are total of few techniques, which is first is phobia of a vamp curl to remember non-polar hydrophobic side chain amino acid. Another is non-polar hydrophobic aromatic amino acids, which are aroma of pine and timber tree. Another come take gas for remembering polar neutral hydrophilic side chains. Blue contain acid for amide containing side chain and hydrophilic negatively charged or side chain, acidic side chain. Alcohol taste sour to remember alcoholic side chains. Then supply chain management to represent sulfur containing side chains. Last action hero to remember hydrophilic positively charged or basic side chain. Then private timber hall to recall all the essential amino acids, where in private P represents phenylalanine, V represents valine, T represents thiorin, another T represents tryptophan, I represents isoleucine, M represents methionine, H represents histidine, A represents arginine, L represents leucine, and another L represents lysine. Now, the important thing that you need to remember is 3-letter code and 1-letter code. Okay, so there are total 20 amino acids and 3 or 4 non-standard amino acids, 20 standard amino acids, which are alanine, abbreviated as ALA in 3-letter code, and 1-letter code it is A. The things that you need to remember are only aspartate. Aspartate is represented by D. Okay. Glutamate represented by E. Phenylalanine represents by, you can represent that by F. Now all are same, but you can see here lysine is represented by K. Okay. Because alanine does not contain it only contains carbon and hydrogen. It is aliphatic. They have non-polar nature, and at pH 7 they are neutral. Why we are studying at a pH 7.4? pH 7.4 is the physiological pH that occurs in our body. The blood pH is also 7.4. So most of the enzymes that occur, that functionalize in our body, they occur at a physiological pH. So we need to know what are the different amino acids that which charge they hold at physiological pH. So normally the aliphatic side chains, they are neutral at pH 7.4. Why? Because they only contain aliphatic they only contain the carbon and hydrogen in their side chain. Other than that, you can see the acidic amino acid holds negative charge, and the hydropathy index is also shown here. Hydropathic index will be discussed later on. Okay, molecular weight also you can remember, and genetic coding. Why this column genetic coding I have given you? Because because these proteins or these amino acids are the building block of protein, right? And how these amino acids are formed? They are formed by you must have gone through in the first lecture itself. Ma'am has discussed about the central dogma of biological system. Central dogma. What does the central dogma tells you? Central dogma tells you DNA to RNA and then RNA to protein. Right. So DNA to RNA. Can somebody tell me what is this process called from DNA to RNA conversion?
Transcription, sir.
Transcription.
Very good. And from RNA to protein?
Translation.
Translation.
Very good. So that is the central dogma of any biological system. Why this has been chosen? Now, why we call this process as translation? Because DNA is nothing but the string, like kind of, if you are aware of this computational, like this computer science one programming course is there, C programming. In that C programming, what you see that the different letters are there, or all the strings are represented by 0 and 1, right? 0 and 1, right? So now in DNA, this DNA is the basic information, the complete information about any human or any biological system, that is encoded in their DNA. And those are encoded in only 4 letters, which are A, T, G, C. And these are nothing but nucleotides. So the arrangement of this ATGC in different fashion can differ in all genes, and the different genes of a particular different human, whether be it me, you, or anybody else, they all contain DNA, and the entire DNA is encoded in these 4 letters ATGC. Now when this ATGC information is passed on to RNA, RNA has RNA take this as a message, and it reads this ATGC as AUGC, where T is replaced with U, which is uracil. In place of thymine in RNA strand, these two are the nucleic acids. DNA is nucleic acid, RNA is nucleic acid. Okay, but in place of T in RNA, you will have uracil. T represents thymine. T is the thymine. A is adenine, thymine, then adenine, guanine, and cytosine. Right. In place of thymine, you have uracil. So normally, what is happened here? Now the information, like you can imagine that this is an English word, and now you have translated it to a Hindi. Okay, so this is kind of a translation only changing one letter, and then you are passing on this message to complete a, like, to make a kind of a system protein, because all the functions that is being carried out in our body, whether like catalysis, whether it is chemical reaction, whether it is sensing, or whether it's like information transport, or anything, the structural thing, that all things are carried forward by the protein. So what now we are doing, what now this is being done here, the first it is transcribed from one information to another information, that is why it is called as a translation. And now this is called as a transcription, because we are just transcribing, and now from this thing is, once we read the 3-letter codon, which is called the genetic coding, then a particular 3-letter code of this messenger RNA, this particular 3-letter code can be translated into 1-letter code, which is protein. Okay, so here A does not represent adenine, so it represents alanine in protein, right? So now we are translating one information to another information from nucleic acid level to protein level. That is why this process is called the translation, right? DNA to RNA, transcription, because we are changing one letter. Now RNA to protein, it is translation, because from one language you are changing this to another language. Okay, that is why it is called the translation. Now for all amino acids, there are 3-letter codon. Okay, for some amino acids, there are more than one 3-letter codon. Okay, these are leucine and some other that we will be giving here. Now, methionine is represented as M. Another thing you need to remember is glutamine, which is represented by Q. Arginine, as the word says, R already included, so you need not to stress more about to remember that, because arginine itself, the phonetics comes as R. Another thing you need to remember, tryptophan represented by W, tyrosine represented by Y. Okay, and these are the three-letter codon. Now, here I have given the pK value of different groups that are present there. In alanine, there is no side chain, so only the pK1 and pK2 value will be given. That will be for COH and NH2. Okay, because in alanine, it does not its side chain is only CS3, so that does not impart any much kind of impact on its pK value, the entire amino acid pK value. So that is why R group pK value is not given, but for cysteine, aspartic acid, glutamic acid, because alanine is aliphatic only, but cysteine, aspartic acid, glutamine, phenylalanine, these three have like either a carboxylic group or COH group or SH group in their side chain. Because of that, they have another pKa value of their side chain, right? So then if you know all these pK1, pK2, then you can then you can calculate the pi value, which is isoelectric point of that particular protein. Why isoelectric point is important? Because to know which charge, because at the isoelectric point is that pH value where the amino acid exit in its deuterionic form. And what are deuterionic form? Where the net charge on that particular protein is 0. Okay. So based on this understanding, whatever I have discussed here, the different pK1, pK2 value and R group, I have designed some questions here. So try to answer this question. So the isoelectric point of an amino acid is defined as the pH where the molecule carries no net charge, or the pH where the carboxylic group is uncharged, amino group is uncharged, or the maximum electrolytic mobility. So can somebody answer? Option A, very good. That is what I have already discussed, that isoelectric point is the pH where the molecule carries no net charge. So if charge is not there, then in the electric field they cannot move. So option D is incorrect. Then because they are having no net charge, so obviously the two other options are also incorrect. Now question number 10, if pK1 is representing what does it represents? The pK1 for COH, right? And pKa2 is for amino group, NH2 group. So if pK1 is for a particular amino acid, if pK1 is 2.34 and pK2 is 9.6, then what would be the value of isoelectric point of this? Can somebody tell me?
D.
Calculation of pi?
Option D. 5.97. D.
Okay.
5.97.
Very good. How do you calculate it?
So
What
we
is
will
pi?
we will take the average of both pKs. So 2.34 plus 9.60 upon 2.
Very good. pK1 plus pK2 divided by 2. So now when amino acid, so option D is correct here. When the amino acid alanine, which having the R group as CS3, is added to a solution of pH 7.3, the alanine occurs as an which form? Deuteric form, deuterion, cation, anion, or isotope. In which form it will be existing at pH 7.3? Can someone answer? To know this, you need to remember what is the pi value of alanine, right? If pi value is equal to pH value, then in that case it will exist as a deuterium form. Okay. If pH of that particular solution is less than its pi, it will in which form it will exist? If pH is less than pi, can somebody tell me?
Positive. If pH is less than pi,
Pi.
it will. I think it will exist in positive form, cationic.
And if pH is greater than pi,
So the negative. I am confused. I am not. Very much.
okay. To resolve that confusion, I will be giving you the complete kind of a titration curve. I will be telling how to calculate and how to remember this all things to sort down all these things. So right now, the pi of a amino acid is 7.3. Pi of this alanine amino acid is 7.3. In that case, this will exist as a deuterium form. Okay. Now the alpha amino acid have a carboxylic group of pKa around this and amino group with a pKa near to this. So what is the correct answer here? What is the common pKa value of a alpha amino carboxylic group?
Sir, A 2 and 9.5.
2 and 9.5. Very good. Normally, the pK alpha carboxylic group, the pK of that particular alpha carboxylic group is around 2, and for the similarly the alpha amino group has the pK of 9.5. Okay, so this can be a kind of a conceptual only the like remembering based techniques. You can remember this value and then the question can be asked in your like competitive exam or your in semester exam. So remember this.
Actually,
Now,
sir,
yes.
can you explain the question number 11?
Yeah, that is what I am going to do now. So to know how this thing can be given, like how to recall these all things, let me tell you first thing like normally let me add another slide here. Yeah. Is my screen visible now? Right? The complete blank screen. So let us say this is alpha carbon. Alpha carbon will be attached to a carboxylic group. Right? And another group will be amino group. Okay. Then H and R group. Okay. So there will be different pKa value. This the pKa1 and pKa2. Now, normally the proteins are in physiological pH, and at the physiological pH, the pKa1, as we have discussed in the question number 12, the pKa1 of a alpha amino like alpha carboxylic group will be around 2, right? And for pKa2 which is amino group, the pKa value of amino group, alpha amino group, not any amino group. I'm talking about alpha amino group because it is attached to the alpha carbon, and alpha carboxylic group, pKa1 alpha carboxylic group is around 2, and pKa2 is for alpha amino group, which is around 9.5. And what is the physiological pH? Physiological pH is 7.4. Right. Now tell me, at the physiological pH, how this amino acid will be represented. Only the information is given to you this, like irrespective of side chain. Sorry. irrespective of side chain. If these informations are given, then at the physiological pH, what will happen? Because pKa1 is around 2, which is less than the 7.5. So how you will assure whether this will be in positive charge, this particular will be in positive charge, or this particular will be in positive charge, or in which charge it will exist? You can you can recall pH is, what is the formula of pH? pH is minus log of H plus, right? pH is nothing but minus log of H plus, where if pH is higher, then this means the concentration of H plus will be low because negative sign is there. So it will be indirectly proportional, right? So at higher pH, concentration of H plus is low. It is similarly at lower pH, the concentration of H plus will be higher, right? So now let us imagine at the condition when pH is less than 2. pH is less than 2, it means the concentration of H plus is much more higher than the pH is when pH is 10, right? Here the H plus concentration will be higher and here H plus concentration will be low. So how to call? Then at pH 2, at pH less than 2, the concentration of H plus will be higher. In that case, this alpha amino group, alpha carboxylic group will not hold its H plus. It will give away the H plus. Okay, at the acidic condition. And at the basic condition, oh sorry, I gave you the wrong information actually. At the acidic condition, all the carboxylic acid will be holding its proton in acidic condition, and at basic condition, why it is called basic? Because in basic condition the proton holders will lose its proton, and at the acidic condition the proton holders will be having its proton. Okay, so now redefine these things at the physiological pH. This at the physiological pH, because pKa value, which is for the alpha carboxylic group, is 2 at physiological pH, which is pH 7.4. Sorry, I have written 7.5. So at physiological pH, the pKa1 is less than pH value, which is 7.4. Right. So at this condition, because this condition is basic condition, at this basic condition, the OH group of this alpha carboxylic group will lose its proton. So thereby at the physiological pH, it will exist in the negatively charged. At physiological pH, what will be the case of amino group? Because pKa2 value of pKa2 is 9.5, which is greater than the pH value, which is 7.4. So in that case, it will hold one more proton. Okay, it will accept one more proton because nitrogen can have one more state. So it will be existing as a positive charge, and this will lose its proton and it will exist as a negative charge. So that is why we now what we see a deuterionic form. Okay, now let's do the titration. So normally when you write a pH at pH 7.4, you will write a general amino acid like this. Okay, the carboxylic group will be deprotonated and amino group will be protonated because the pH is 7.4, and to lose the proton from amino group, it needs to be equal to 9.5 or more than 9, equal or more than 9.5, then only the amino group will lose its proton. Okay, and pK alpha carboxylic group will lose its proton at pKa of 2, around 2. Okay. Now let us check this titration of arginine. Okay. So this is, let us say you have a amino acid which is arginine at pH of if you are doing a titration, if you are doing the titration of amino acid, arginine amino acid, this is arginine, right? So in arginine amino acid at pKa of less than 2, when the pH value is less than 2.2, because pK1 is for alpha carbonyl group, this is alpha carbon, right? For alpha carbonic group, when the pH value is less than 2.2, then this will be in the protonated state. So the net charge of this amino acid will be +2, right? But at pK1 of 2.2, which means at pH value of 2.2, this amino group, alpha carboxylic group, this alpha carboxylic group will lose its proton and it will hold a negative charge, right? But neither the alpha amino group nor the side chain amino group will lose its proton because they will lose at higher pH, right? So till from pH 2.2 to 9, it will exist in +1 charge, right? It will exist in the +1 charge because these charges can now there are two positive and one negative. So net charge is +1. Now at pK value of 9. Now to lose the proton from alpha amino group, you need to have the pH of 9.5, right? So at pH 9, this particular amino acid in this arginine, the side chain will lose which amino group will lose its proton first, whether it will be of alpha amino group or side chain. Of course, it will be the alpha amino group first. It will lose the proton, right? Because side chain will lose the proton at higher pH than the alpha amino group, right? So at pH below 2.2, the protein, this amino acid will exist in +2 charge. Greater than 2.2, the alpha carboxylic group will lose its proton and the net charge will be +2. At pH higher than 9, the alpha amino group will lose its proton and then the net charge will be 0 here, right? Including the side chain. Now, at pH higher than 10.5, this side chain will also lose its proton and then your net charge will be -1. Okay, so why have I told you this? Because when you are calculating the pH value or PI value, when you are calculating a PI value of any amino acid, you need to know the pK1 value and pK2. And if there are amino acid like amino group or carboxylic group attached to its side chain, they will have another pH another pK value which will be termed as the pKr, pK value of side chain, right? In that case, you will be you will not be able to identify which two pK value you have to take and average to calculate the PI value. Okay, so to remember that, what you need to know, you need to take only those pH value where the charge is changing from +1 to 0 to -1. Wherever you see this particular transition from +1 to 0 to -1, that pH value you will be taking, and then you will be calculating the PI value of that particular amino acid. Okay, so in case of arginine, here this transition is known as the +1, 0 and -1. Thereby, you will take the pKa value, these two pK value, to calculate the PI value of arginine. Okay, so that is what to calculate how about the PI value. And similarly, during while discussing this, I have told you how the particular amino acid will change its state from one charge value to another charge value depending on pH. So is that clear now to everyone, or you are more confused? I can again discuss. Is it clear to everyone?
Sir, no, sir, can you please repeat it?
Okay, so let me first repeat by first I will take the simplest. First, I will take the simplest amino acid. So that is clear, right? At pH 7.4, at physiological pH, the amino acid will exist in a deuterionic form. Is that clear?
Yes,
Yes,
sir.
sir.
Yes. Okay. So then I will be moving forward from here. So deuterionic form is this: alpha carbon, alpha carboxylic group, then alpha amino group, then this is R, this is H. Okay. Now, this is deuterionic form at pH 7.4. Now let us take, now you do the titration. Now you do the titration. Okay. So at pH greater than 7.4, as pH greater than 7.4, what will happen? pH greater than 7.4 means H+ concentration is decreasing, right? Decreasing because at pH there will be some H+ concentration. When you are increasing the pH increases means H+ concentration will be lowered, right? Because it is tending to the basic version. So in case of base, when the base concentration is increasing and increasing and increasing, so in that case, this particular amino acid, like this alpha amino group, will also lose its proton. Okay, so in that case, the protein will exist in the, like this particular amino acid, this is already negatively charged. Carboxylic carbon is already negatively charged. Now, this hydrogen will also go and it will exist in a kind of a no charge on the amino acid, on this amino group, right? Because at pH greater than pKa2, at pH greater than pKa2, pKa2 is what pH value? pKa2 is the pH value when alpha amino group also loses its proton. Okay, so in that case, the amino acid will exist in negatively charged, because here no charge is there, but at carboxylic carbon there is one negative charge, so it is -1. Okay, so at pH greater than 7.4 or at pH greater than pKa2 value, the protein will the amino acid will exist in negative charge. But in case of now let us consider the situation where pH is less than pKa2. pKa1, sorry, pKa1 less than pKa1. What is pKa1? pKa1 is the pH value where the alpha carboxylic group of an amino acid loses its proton. Okay, so at pH lower than pK1 value, that means now when the pK1 value is lower than the pH value, in that case the H plus concentration is increasing in the surrounding, right? H plus concentration is higher. When H plus concentration is already higher, then carboxylic group will also not lose its proton, right? So in that case, carboxylic group will hold its proton, and amino group is already charged. It is already charged, right? So at pH lesser than pKa1 value, it will exist in a positive charge, and at pH equal to pi, it will exist as a net charge 0, which is deuterionic form. So that is why, so we remember this concept all together. Whenever you are calculating the pi, you need to take those reading, those pK value reading where the charge is changing from +1 to 0 to -1. Okay, remember this concept. So this will be the pK1, this will be the pK2, and you will take the average value to calculate the pi. Is it clear now? For general amino acid, why it will exist in the at higher pH, why it will exist in the negative charge, at lower pH, why it will exist in the positive charge. Is it clear to everyone now?
Yes, sir.
Very good. So for general acid, it is clear. Now I will tell you how to calculate for positively charged amino acid. And this is for the general. Similarly, I have this graph represents at like if you are doing a titration, you are increasing the pH, and there are amino acid. Okay, at lower pH, lower than the pH value when pKa, normally for general amino acid pK1 is 2, right? So at lower pK1, there will be not more deuteric ionic form, but you will have the both amino group and carboxylic group protonated. So you will find the protonation much more prominent in case of pKa pH value lesser than P2. At lesser than 2, both will be protonated. But once you hit pH value of 2, means you are going in forward direction. Once you hit pH 2, then the deuter ion form will tend to increase, right? Okay, and once you reach the pi value, which is the average of +1 state, 0 state, -1 state. Once you hit the pi value, then the most prominent thing you will see is the deuterion form. Okay. Now let us say you have crossed the state at pH 9.5. Till pH 9.5, once when you have not hit it 9.5, you will be few of the amino acid will have this deuterionic form, but once you cross this state, the deuterionic form will decrease, and you will see both alpha amino group and alpha carboxylic group both are deprotonated, and you will see a state -1. The same information that I have discussed earlier, now that is represented by graph. Now let us discuss for a positively charged amino acid. For positively charged amino acid, what you will see, apart from the alpha amino group and alpha carboxylic group, you will also have a side chain in which amino group is there, which is arginine, right? So in case of pH lesser than 2.2, when your pH is lesser than 2.2, that means you have not hit pK1, where the alpha amino group, alpha carboxylic group will lose its proton. So once you cross pH 2.2, alpha carboxylic group will lose its proton. It will exist in the negative charge. Then the net charge on the protein will be +2 -1, which is +1. Here the net charge is +2 and 0. So here it is +2. Now from pH 2.2 to 9. Okay, from pH 2.2 to 9 for arginine, it will exist in +1 charge. But once you hit pK or pH value of 9, the alpha amino group will also lose its proton, and thereby it will result in a which form? Deuterium form. So here net charge is 0, right? Positive and negative, positive, negative, 0 charge, right? So now this stage is 0, net charge is 0. Till pH 9, the side chain will not lose its proton. Once you cross, because the side chain pH, for losing the side chain proton, you need pH of 10.5. That is what we have discussed in this table, right? For case of, let me show you the arginine. Here arginine. Arginine is here, yeah. So a 1.8 is the pK1, for pK2 is 9, and for R group it is around 12.48, right? So once this crosses pH of 10.5, this amino group will also lose its proton, and then there will be a net charge of -1. Understood? So for calculating the pi value, you will not take this average of these two pH. You will not take the average of these two pH, but you will take the pH value of this one and this one. And for calculating the pi value of arginine, you will take 9 plus 10.5 divided by 2. And there how you calculate the pi value of any branched R group containing amino acid. The important thing that I want to discuss about histidine. Histidine titration is not as simple as it seems. Other amino acids, which pi is ranging from either in the basic region or in like acidic region. But for histidine, its pi is about 6. Okay, it ranges between the it ranges in the physiological pH. It is more closer to the physiological pH. Okay, so because of that, what happens? Depending on the type of amino acids present surrounding the alpha, like histidine carbon, it changes its pi value. Okay, so the black line represents in normal case, okay, the single histidine compound. But when histidine is surrounded by positively charged amino acid, what are the different positively charged amino acid? Can somebody name?
Sir, histidine, arginine, lysine.
Yeah, arginine and lysine. Other than the histidine, arginine and lysine are the positively charged amino acid. Okay, so if you see a protein, because in protein there will be a multiple number of amino acids. If histidine is surrounded by positively charged amino acid, then its pi value will shift in lower pH. Okay, and it will hold a positive charge around its surface. Okay. If it is surrounded by negatively charged amino acid, then its pi will range up to 8. Okay, up to 8. Thereby, the pi value of histidine covers entire spectrum of physiological pH. Thereby, you will see the histidine amino acid in most of the active site. Okay. Once you go further and you study protein biochemistry and enzyme kinetics and other subjects, there you will see, and if you are doing a docking kind of study, molecular docking, GROMACS, then what you will see in most of the catalytic site, histidine amino acid will be present. And the reason of that particular enzyme is this only, because its pi ranges from a very wide range. It covers entire spectrum of physiological pH, and most of the enzymatic reactions occurs at physiological pH. That is why histidine is found in the most of the active site. Okay. Hope it is clear to all of you. Can I move forward?
Please, sir.
Yeah, sure. Okay, so the next questions are: which pair of the amino acid absorbs the most UV light in 280 nanometer? Tryptophan tyrosine, tryptophan histidine, phenylalanine proline, or tyrosine aspartic acid?
Sir, option A.
Very good. Why? Why do they observe UV light at 280 nanometer?
Sir, because they are aromatic amino acid and they are optically active.
Why they are optically active? What does the aromaticity has to do with it?
Due to presence of cyclic structure, I think.
Cyclic structure. So why proline is not giving the UV light absorption? It also have the cyclic structure.
Resonance.
Resonance, very good. And why resonance participate in this absorption of UV light? Okay, so we will discuss due to the presence of
free electrons.
Free electrons. Okay, no problem. I will discuss this in greater details. Yeah, I will discuss that in greater details. Now, question number 14. The answer was correct, tryptophan and tyrosine. The next question is, which among the following is correct about the absorption spectra of amino acid? Bathochromic shift occurs when polarity increases. Hypsochromic shift occurs when polarity increases. Hypsochromic shift occurs when hydrophobicity increases, or bathochromic shift occurs when hydrophobicity increases. Can somebody answer it? What is bathochromic, hypsochromic, and hypochromic? Can somebody tell me?
Associated with increase or decrease of wavelength.
Sorry, yes.
These are associated with the increase or decrease of wavelength.
Yes,
and frequency.
very good. Very good. So what will be your answer here?
B option, sir.
Option D.
B, second.
B.
Yeah.
Okay. Any other answer?
I don't know concepts and logic, but I give that option is C option.
Option C. Any other options? Okay, correct answer here is option B. Hypsochromic shift occurs when polarity increases. That I will discuss in greater details in upcoming slides. Now, question number 15. A buffer solution is prepared by mixing 1 mole of HA and 1 mole of NaA, okay, into 1 liter of distilled water. Calculate the change in pH when 25 ml of 20 molar NaOH is added into a 500 ml of buffer. Given that Ka value of weak acid is 1.75 into 10 raised to minus 5 molar. Can someone quickly calculate, or if they know the trick to answer this?
Option C, sir. 1.08
Option C.
C.
Okay. Any other options? Are there any other option? Okay, I will discuss this question, like how to calculate these properties and how to perform this in the upcoming slides. So leave this answer right now. The another question is, a buffer is prepared with using 1 molar of HA and 1 molar of its conjugate base, where A correspond to an anionic group. pK of HA is 4.87. The pH of resulting solution will be, what will be the pH? To solve both of the question, you need to know the Henderson-Hasselbalch equation. Okay, so Henderson, yeah.
In option
Option
A.
Option A. Okay, so do you remember the trick, or you know how to calculate it? Okay, we will try this question in upcoming slides. First, discuss option A, right? Yeah. Let me first discuss the question number 13. Yes, yes.
Okay, so one second. No, sir. No problem. No issue.
Yeah, you can answer, no problem. Yes.
No, sir.
Okay.
Nothing.
So let me first discuss the question number 13 and 14, which is related to the absorption spectra. Okay. So for absorption spectra, normally why we study this like U absorption. So normally absorption occurs due to the due to the different orbitals in the molecular structure. If you have remember the molecular orbital theory, in molecular orbital theory, how you do, there are different types of bonding depending on the where the electrons is going to fill the orbitals. Okay, so that is the core chemistry thing that I will be giving you the this is important for most of the concepts, like to understand the absorption, fluorescence, and phosphorescence, and there are various topics. So here, to brief you about this, there are kind of total these 5 types of bonding that can occur. So in sigma bonding, that makes a sigma like only what you say, only a single bond. Sigma bonding means participation of 2 electrons, and then they make the sigma bonding is the strongest bonding. Okay, now pi bonding is making a double bond, non-bonding orbital, then anti-bonding orbital, and anti-bonding orbital, which is sigma star, and pi and sigma. So when you rank them into the energy diagram, so because sigma bonding is the most stable bonding, it will have the lowest energy. Okay, then followed by the pi bonding, because pi bonding is coming after the sigma bonding in strength. It will have the it will be close to the sigma bonding. But in comparison to the energy level, the pi bonding will be greater than the sigma bonding. N is the non-bonding orbital, then pi star and sigma star. These are the high energy level. Okay, so the absorption occurs because of when in a structure there is an electron delocalization, means because in phenyl aniline and tryptophan both have benzene ring and they have electron delocalization. This electron can participate in the resonance. Okay, so and the filling of electron is also important. Of in which or binding orbital these electrons are present. Now, when there is a sigma bond, it usually exists in the sigma bonding orbital. Okay, the pi electrons are present in the pi bonding orbital. Now, because of the energy difference, what happens when when you expose this light, because the light is the only in light that we see is the visual light. The visual light is only a small part of the electromagnetic spectrum. Okay, from 400 nanometer to 700 nanometer. 700 nanometer is the red light area, while a blue below you ultraviolet, like after ultraviolet, this violet region is the lowest wavelength region of the visual light. Below it will be UV, and after the red region, you will find the infrared region. The FTI spectroscopy, which is about the fluorescence transform infrared spectroscopy, and UV is for the UV visual spectroscopy and also for fluorescence. Okay, so what is the impact of this different energy region, this electromagnetic region? Because depending on the range, depending on this crust and trough, the electromagnetic spectrum, this wave, depending on its wavelength, it contains a certain amount of energy, which can have impact on electrons, which can have impact on the bonds that are present. When you are studying the different vibration in the bonds and rotation, vibration, and different type of characteristic of a particular bond, then that will focus on the infrared region, and that is what you study in FTIR. But when you are studying the property of electrons, because in the range of UV light, when you impart the energy from the UV light to a structure, chemical structure, then electrons can accept those energy in form of photon package, and then they can make the transition from one energy level to another energy level. Okay, so there is a light source. That is the basic of UV visual spectroscopy. There will be a light source that will be passed through a lens, and this energy will be condensed. Then that will be passed through a grating, and which will select a particular wavelength. So once you are selecting a wavelength of that particular particular wavelength represents the particular energy. Lesser the wavelength, the energy will be higher. Higher the wavelength, the energy will be lower. Okay, remember this. So once you are in the UV region, that means it will have the higher energy than the visual light. Okay, so once you go below this UV region, once you go below the visual light region, the energy will increase. Okay, so thereby the UV region is also divided into three different categories. First one is near ultraviolet region. Near ultraviolet region are those regions which is comparatively nearer to the visual light, which is from 250 nanometer to 400 nanometers. Because 400 nanometer is visual light, So this region will be near UV, which is also called UVA, UVA or UVB. Okay. Now far UV region, which is from 190 nanometer to 250 nanometer, that is called as a far UV region. And vacuum UV region is lesser than 190 nanometer. Once you cross the 190 nanometer region, that is called as a vacuum UV region. And this region is essential when you are making changes in the sigma bonding. Okay, in the lower, like in the vacuum UV region, normally this occurs when you are recording when you are recording a CD spectra. In CD spectra, you can operate that from 190 nanometer to 250 nanometer. Okay. So here, depending on which light you are imposing, the electron will have the tendency to move depending on that, right? So in newer UV region, which is 250 to 400 nanometer, which is mostly used in the UV spectrophotometer, that makes an important transition in electron, like in case of transition of electron from lower energy state to high energy state. Okay, so for sigma to sigma star transition, because this energy gap is very much high, and that can only be filled by the higher energy light, and which is UV vacuum UV region. So normally this is forbidden. Sigma to sigma star transition is forbidden. Okay. Now if you make a transition from pi to like n to pi star, then n to sigma star transition, and sigma to sigma star transition, sigma to pi star transition. Okay, this is sigma to pi star transition. So UV near UV region can make the transition only in pi to pi star transition and n to pi star transition. Okay, because these are the shorter energy requirement. This is what is used in tryptophan, phenylalanine, and tyrosine. The pi bonding in benzene ring takes the energy in pi to pi star transition, and then they can absorb the light, and they will, like, once the absorption of light is done, that is being recorded in UV spectrophotometer, and that's what you observe, which kind of light has been observed. Okay, so peptide bond in protein, peptide bond results in 190 nanometer, which is pi to pi star transition. N to pi star transition is 220 nanometer, and pi to pi star transition, which occurs in tyrosine, tryptophan, and phenylalanine, that occurs in 280 nanometers, which falls in near UV region. Okay, 220 nanometer is used to take the recording of backbone. Like when you are studying the protein structure using CD spectrophotometer, in CD spectrophotometer you record pi to pi star transition and n to pi star transition. Okay, pi to pi star transition is 190 nanometer, n to pi star transition is 220 nanometer, which falls under far UV region. Okay. Now, once this is done, then because of this pi to pi star transition, the most UV, the 280 nanometer is observed by the aromatic amino acid, which is tryptophan and tyrosine, because there occurs pi to pi star transition. Okay, is that understood? Is that clear to everyone?
So once again, question.
Question number 14 I will be discussing. Till now I have discussed the question number 13.
Okay, sir.
Yeah. Now coming to the question number 14. Question number 14 is related to the shift in spectra. Why shift in spectra occurs? That occurs because of the more elongated delocalization. Like when electron can have more delocalization, depending on that, it can show it electromagnetic the UV absorption spectra can shift either in the positive direction, either in right side or in left side. So bathochromic shift are called red shift. Okay, bathochromic shift are called red shift, and that can occur when hydrophobicity is increased. But when polarity is increased, in that case, hypsochromic shift is noticed. Okay, there are four terminology: hyperchromic, hypochromic, bathochromic, and hypsochromic. Okay, now hypsochromic is blue shift, means the spectra will move towards left side in like in UV spectra. UV spectra will shift towards left side, that is hypsochromic. Hypsochromic means lower region, like lower wavelength. Lower wavelength means it will move towards blue light. So that is why it is hypsochromic. Bathochromic means it is moving towards right direction, means higher wavelength, means red shift. So bathochromic shift are red shift, and hypochromic and hypsochromic are like hyperchromic and hypochromic are when this peak shift is observed in the up direction or down direction. Okay, when peak is decreasing due to some different compound that is present in there. So when there is a heteroatom present in kind of compound, normal compound. Okay, let us say in addition to the benzene ring, let us say you have a benzene ring, then there will be a certain kind of spectra. You will observe a certain absorption spectra. But when you attach one more benzene ring, this will shift to the leftward, because in case of naphthalene, anthracene, tetracene, and naphthalene, anthracene has 3 benzene ring. Anthracene has 3 benzene ring. So when you reduce one chain, the electron delocalization has decreased, so it will shift to the left direction, and you will observe a hypsochromic shift. Because one ring is reduced, the polarity will also decrease. So once the polarity is increasing. In case of polarity is increasing, you will observe hypsochromic shift. When you add on one more ring to anthracene, that will result you a tetracene. And in case of tetracene, you will see a right shift, which is bathochromic shift. And that is because hydrophobicity increases. Why hydrophobicity is increasing here? Because you are increasing more number of carbon and hydrogen. Okay, here you are decreasing number of carbon and hydrogen, thereby the polarity is increasing in leftward. Here you are increasing carbon and hydrogen, so your polarity will decrease, hydrophobicity will increase. So more hydrophobic, bathochromic shift; more polar, hypsochromic shift. Is that understood? Okay, so now once you have understood the chromophoric shift, now the important thing to discuss how to calculate the different like kind of a absorption of light using a particular compound. Okay, that is given by the Beer-Slamber's law, epsilon Cl. This is Beer-Slumbers law. Okay. So now we have understood that in a protein, only 3 amino acids will absorb the UV light. Right? Those are tyrosine, tryptophan, and threonine. Right? Okay. So here it is given. Have I said it wrong? These will be phenylalanine, tyrosine, and tryptophan. And phenylalanine is represented by F. Right? If I am saying anything wrong, you should catch me and correct it. That was a kind of a cross-checking. No one of you noticed. So phenylalanine, tyrosine, and tryptophan are the 3 amino acids which can absorb UV light because of conjugation or aromatic ring present in it, and because of pi to pi star transition, they can absorb the light at 280 nanometer. Okay, so at 280 nanometer, you have to calculate the epsilon, which is molar absorptivity coefficient, theoretical estimation of molar absorptivity coefficient for 280 nanometer. And if you are given a protein and you know the number of tryptophan residue and number of tyrosine residue in that, so then you can calculate the molar absorptivity coefficient, and that formula is number of tryptophan residues multiplied by 5690 per molar per centimeter, and number of tyrosine residue into 1280 per molar per centimeter. And once you calculate the molar absorptivity coefficient, then you can calculate the absorption of that particular protein. Okay, now let's discuss the question number 15, which was the question to calculate the you have to calculate the change in pH. Okay, so to calculate that, you need to have how you will follow in that, how you will do the solution. First, write the chemical equation of this buffer. The chemical equation of this buffer means it has the HA acid, which is weak amino acid, weak acid, and then the conjugate base is NaA, salt, right? Salt of it. Then the buffer equation of buffer will be HA plus NaCl, HA plus NaOH or anything, NaOH you write. It will form water H2O plus Na, right? This will be its conjugate base. Okay, you can also represent it as HA and Na, right? So now write the chemical equation of buffer. HA plus water H3O plus A minus, which is representing the conjugate base NaA. Now you have given the Ka value of weak acid, which is 1.75 into 10 raised to minus 5. Okay, so the pKa will be minus log of H plus minus pKa will be minus log of Ka. So you put the Ka value. Now the equation will become like pKa is equal to 5 minus, because if you solve it, minus log of H plus, this will become minus log of 1.75 and minus log of 10 raised to minus 5, which will give you minus log of 1.75 and minus plus, this will be 5. So 5 minus log of 1.75. and then you will get pKa will be 4.757, right? Now you have calculated the pKa. So the given is moles of HA was 1.1 mole. Then moles of salt was also 1 mole. The volume of solution given as 1 liter. Right. Now you can calculate the pH of original buffer. That will be equal to the concentration of HA. For calculating the pH of buffer, you need pH will be what is the Hasselbalch equation? pH is equal to pKa plus log of concentration of conjugate base by concentration of acid. So concentration of acid is equal to the concentration of conjugate base. Both are given as 1 mole, right? So the concentration will be 1 molar. So pH will be 4.75 plus log of conjugate concentration of conjugate acid, conjugate base divided by concentration of acid, which is 1 mole each, 1 molar each. So thereby pH will be 4.75. Okay. Now the next part is next part of the question was you have added 25 ml of 0.2 molar NaOH in this solution and added 50 added to the 500 ml of buffer. Okay, so what will be the change in pH? So now you have calculated the pH of original buffer. The next thing is how many moles of OH has been added. So 25 ml, which leads to the 0.025 liter, and molarity of it was 0.2 molar. You have added that to a 1 liter solution. There was 1 liter solution, so moles of the moles of this OH minus will be around 0.005. That will be the molarity of the solution. Now volume of buffer that has been taken as 500 ml. So 500 ml means total of 0.5 molar solution, right? Now there was, because it initially it was in 1 liter it is 1 molar. If you have taken 500 ml, so it will result you the 0.5 molar solution, 0.5 molar, and then you are neutralizing that with the 0.005 molar of base, which is NaOH.
Sir, your voice is not coming properly.
You have been muted, sir.
सर माइक ऑफ हो गया.
Is it audible now?
Yes,
sir.
sir.
Sorry for the interruption. Okay, from where you were not able to listening? So you understood how the moles molarity of base was calculated, right? 25 ml was given, 0.2 molar was given, and 1 liter solution. So the molarity of base is 0.05. The moles, this will be the moles. Okay, 0.05 moles. Now the volume of buffer was taken as 500 ml, and therefore it will have 0.05 moles, 0.5 moles. Now you are neutralizing, titrating that acid with the base. So thereby at the end you will have a total of these many moles. These all are moles. These many moles, 0.45 moles of acid, and for base it will be 0.505 moles, right? So the pH of new buffer will be pH equal to pKa, which is same 4.757 plus now conjugate base concentration of conjugate base is 0.505 and concentration of acid is 0.495. Thereby you will have 4.757 plus 0.09. If you calculate the log of this value, it will lead to 0.009 and that will lead you 4.766. So you have been asked to calculate the change in pH. So change in pH will be new pH minus original pH, which will be 0.01. Okay. So the correct answer here was option D. Now for question number 16 also, the question is answered during the like here itself while we were discussing the calculation of pH of original buffer. So when we are calculating the pH of original buffer, when you remember this concept, when the concentration of acid and concentration of conjugate base are same, then in that case the logarithmic value will be 0 because log of 1 will be 0, right? Log of 1 is 0. So in that case, the pH will be same as pK when the concentration of acid and concentration of base is same, concentration of its conjugate base is same. In that case, pH will be equal to the pKa. So in that case, the answer is option A. Right. Now, once that is done, we move forward to the next question. Calculate the molar excitation coefficient of 50 amino acid peptide chain that contains a 3 tyrosine, 2 tryptophan, and having a molecular weight of 5.5 kilodalton. Calculate the extinction coefficient and absorption for 0.1 millimolar solution of protein. How to approach it? For this question, because this is related to the UV absorption, so the Beer-Lambert's law will hold epsilon Cl. Do you think this will have any kind of role in calculating the absorption, the molecular weight? No, because it does not hold any significance here. So this is an extra information. Now to calculate how you will proceed, first you have like in the last equation that I had given you, when you calculate the molar adsorptivity coefficient for a protein, you need to know what are the number of tryptophan, what are the number of tyrosine amino acid residue in that, and then what are the number of different phenyl amino acid residue. So based on that, you can calculate the molar adsorptivity coefficient. So here number of tryptophans are 3, number of 3 tyrosine and 2 tryptophan. So here 3 tyrosine and 2 tryptophan. Okay. So and concentration of protein is also given, which is 0.1 millimolar, which means or 0.1 into 10 raised to minus 3 molar. Coming next, calculation of epsilon for protein, 3 number of tryptophan, 2 number of tyrosine, and then you will reach this molar absorptivity coefficient. Now to calculate the absorption, what you will do, you will need absorptive coefficient that you have calculated here. Now extinction coefficient, then concentration of protein in molarity, molar, because you have to cancel out the per molar, and path length is 1 centimeter as given. So then your absorption will be 1.522. Okay. Now hence the protein that contains 50 amino acid residue will show this molar adsorptivity coefficient, and absorption will be 1.522 at concentration of 0.1 millimolar. Next question. The resonance structure that can be drawn for the peptide bond indicates the peptide bond which is stronger than the ordinary single bond, has partial double bond character, or is weaker than the ordinary single bond. So your options are 1, 2, and 3 are correct. 1 and 2 are correct. Or 2 and 3 are correct. 1 and 2 are correct, and 1 and 3 are correct. Tell me about the peptide bonds. What is the correct answer? Option number?
C. First and second are correct.
First and second are correct. Very good. Can you tell me why?
Sir, because the peptide bond is stronger than ordinary single bond because it has partial double bond character.
Okay.
Right?
And why does it have partial double bond character?
Because presence of lone pair on CONS group is there. Presence of pair on oxygen get distributed.
Yes. Yeah, very good. So option C is correct. Now question number 19. The geometry of peptide bond in protein is usually cis when if proline is next to the amino group, usually trans when proline is the next amino acid, planar because of yes. Option D, always a double bond character due to the lone pair donation from the nitrogen. But, yeah. Hello? Am I audible?
Yes, sir.
Yes.
Yes.
So what will be the correct answer for this? Question number 19.
I think option A will.
Option A. Okay. Any other?
Option A, sir.
Option A. Okay, we will discuss about it in the next slide. Question number 20. A tripeptide has 3 amino acids, 1 peptide bond, 2 amino acid, 3 amino acid, 2 peptide bonds, 3 amino acid, 3 peptide bond, or 3 amino acid, 4 peptide bond. What is the correct answer?
A option, sir.
B
option. Option
B,
B.
sir. B.
Very good. So now we will move to this about discussing the peptide bonds. How these peptide bonds are formed? Peptide, normally whenever you form a peptide bond, always remember the first amino acid will have the N terminal and the last amino acid in a peptide will have C terminal at the end. Okay. Why it is called N terminal? Because for the geometry is represented like this. When you form a peptide bond, the first this is the first amino acid, this is the second amino acid. Okay, so the OH group of this carboxylic group, it will form a kind of a peptide bond like this CO group and this NH, and in result the water will be released and thereby you will form a peptide bond which is CONH bond. Now what do you see here? There are 2 amino acids. So when there is a dipeptide is there, then dipeptide involves 2 amino acids and 1 peptide bond, right? Similarly, in case of 3 tripeptide, 3 amino acids will be there and 2 peptide bond will be there. Okay, so and there will be release in 1 water molecule. Now next, coming to the property of peptide bonds. Now here oxygen have 2 lone pairs and nitrogen has 1 lone pair. Okay. Now, because of this 1 lone pair, this participates in the resonance of this peptide bond, because of which it has a partial double bond character, which is approximately to 40%. Means 40% of the time it will have the double bond character, the peptide bond, which is CONH. This bond. This bond will have 40% double bond character, because this nitrogen, the lone pair of nitrogen will participate in the double bond, the resonance, and this double bond will go to the oxygen and it will have the another lone pair. Okay, so thereby, because of this, it has a partial double bond character, and because of partial double bond character, it is planar and rigid structure. Okay, now because partial double bond character is there, so the rotation will be restricted. Okay, normally rotation around the bond occurs when there is a single bond. Because of rotation only, you can have the different conformation like cis form or trans form. Cis form and trans form exist because of the rotation around the bond, and this rotation around the bond you will also study in the upcoming week's lecture, when ma'am we discuss about the protein geometry, like amino acid, like protein geometry, how the bond is being formed, and then what are the different types of bond are there, pi, like sigma bond, like other bond, psi bond, phi bond. Okay, so there is a rotation around the pi bond also, because it has a partial single bond and partial double bond character. It can rotate around it, and thereby it forms a trans and cis geometry. Okay, the 4 atoms that are involved in peptide bond formation, they lie in a kind of a planar structure. Okay, because of partial double bond character, they make a single plane which contains oxygen, carbon, nitrogen, and hydrogen, and they are a relatively rigid plane because of 40% double bond character. Now, why this planarity exists? Planarity exists due to the delocalization of pi electrons that are available on the nitrogen. Delocalization of pi electrons over nitrogen, carbon, and oxygen atoms that keeps the maximum overlap of contributing pi orbital. Because of this, the planarity exists, and these are the different angles, rotational angles that exist around the bond. Okay, those are the phi, psi, and omega that will be discussed in the next week tutorials. Okay, now the next question, which was when there is when there exists a proline in next amino acid, in which form it will exist. So the answer is normally when the C here in the C alpha will be attached to the R group, right? C alpha will be attached to the R group. One R group is there, then another R group is there. Now, due to the rigidity, if proline is attached to a peptide bond, then the transform will be more appropriate, because there will be less steric hindrance between the R group that is attached to the C alpha carbon. So if both are in the same side, if proline exists in cis formation, in that case both R group will be on the same side, means more bulkier group, and that limits its kind of like existence. Thereby it exists in the transform. Okay, so the correct answer here is usually trans, even when even if the proline is the next amino acid. Okay, so this summarized the complete week tutorial and some basic understanding of the biochemistry. Now coming to the GATE Excel for chemistry and biochemistry. Like these, if you go through the syllabus, I will give you a brief kind of a overview how you can prepare for the GATE Excel examination, which is on 11th of Feb. Okay, so I have uploaded all the different resources like previous year question paper and previous year question paper and syllabus, and the study material like the chapters from NCERT that is there in this drive folder. Once you go through this drive folder, you will find two different folders, Excel and BT. BT for the biotechnology gate exam and Excel for the like life sciences. So here you will find the syllabus. Okay, I hope those who are appearing for this exam, they have gone through the syllabus for chemistry and biochemistry. Okay, and for GATE examination in BT, the syllabus is also uploaded here in this folder. For chemistry, here I have uploaded the NCERT chapters. The NCERT chapters which are important and which covers the entire syllabus of this chemistry portion of GATE Excel. The important topics that you need to focus are P block, because once you go through the different topics, like once you go through the previous year question paper that are there in the folder I have uploaded, PYQ folder. So here from 2007 to 2022, the question paper I have uploaded there. So once you go through these questions, the chemistry and biochemistry questions, the portion, you will find that more in the chemistry region, more of the questions are asked from the D block transition metals, T block elements, transition metals, and P block. So you do not forget to revise the like NCERT chapters of P block, D block, and transition metals, coordination chemistry, right? So this is very much important with respect to like chemistry subject in GATE life science examination. Another important topic is reaction kinetics. Okay, lot of question comes from reaction kinetics, where reaction kinetics also include enzyme kinetics, and there will be a overlapping section of chemistry and biochemistry, where in metabolism you will also find enzyme kinetics. To build the concept of enzyme kinetics, you need to understand the reaction chemistry, reaction kinetics. Okay, so these are the two important topics. This is from the inorganic chemistry, P block, D block, and coordination chemistry. You must refer those PDF in the drive folder that I have uploaded. Then you can also expect the question from there will be lot of questions from organic reaction mechanism, SN1, SN2 reaction. Okay, if you see the questions, there will be a lot of organic questions, like organic chemistry questions, which include the named reaction and halogenation reaction and esterification, trans-esterification. Those kind of reaction you will study and that you must refer before going to the GATE examination for chemistry section. Okay, you also need to focus on electrochemistry part and thermodynamics. These will be the related thing. Okay, so you go through the PDFs that I have uploaded. The like last minute thing that you need to focus on, you must go through the summary of each chapters that is like available there. If you go through the folder, like let me open any chapter, chemistry chapter, let us say here electrochemistry. At the end of all chapters, you will find a summary. Okay, so if you have not studied the entire chapter, you must go through the summary. Many of the time the question come directly from the summary also. Okay, you must focus on summary and the boxed thing. Wherever you will find a box, that is must to read. Okay, like in all chapters you will find a box. The important things will be highlighted in a box, and you can refer the example questions that are present in the NCERT book. Okay, if you solve those things, those questions, it will be very easy. Like you will be very much kind of able to solve the questions, basic questions that will be asked in the kit. Okay. The another instructions that I will give you: do not go before like without reading the instruction of the admit card, because many of time they change the instruction in admit card, like instruction for appearing when you are going to appear in the examination. There will be a set of instruction. You must read that instruction carefully so that you don't kind of miss anything while you are going for examination. Okay. Then another thing, the like syllabus that I would like to give you is this. Here you study the rate constant, basic questions, rate constant, order of reaction. Lot of questions are being asked from this thing: rate constant, order of equation, order of reaction, then activation energy, and first and second order kinetics. This is important. Then in P block, coordination chemistry is important, coordination complexes, P block and D block. Okay. Then the related to the general characteristic of P block elements, you must read the chapter of this one, like where I have uploaded the P block chapter. Like these two, from 11th and 12th, you read these chapters completely, like line by line, because the inorganic you don't have to like solve the problem, so the questions will come theoretical. So if you complete this, like this PDF, P block 12th chapter, P block 11th chapter, and the coordination chemistry. Is the coordination compound? Yeah, coordination chemistry. So these three will cover almost kind of 20% question in chemistry. Okay, and one important instruction, that you don't be discouraged whether you will be able to qualify the exam or not. You just need to focus. You avoid of making the negative marking. Okay, why negative marking? Because the cutoff does not go beyond 32 to 33. In most of the like from 2007 to 2022, if you see the cutoff of GATE examination, it lies between 28 to 34 or 33, like that. So you don't have to stress much on scoring like doing all the questions. You just need to get the marks above 45 plus. Your target should be above 45 plus, and then you will come under AIR 300. Because normally AIR 1 of GATE examination, they will have the score out of 100, they will have mostly around 67 to 75, not more than that. And there are relative marking, and the percentile will calculate it based on that. So your AIR, if you score more than 45 itself, you will come under AIR 300. Okay, so first try to clear the examination. So don't don't do the negative marking. You attempt only those questions which are very much you know those questions very accurately and you are very much confident on those questions. Then only you try that. Otherwise, you avoid negative marking. Okay, so I plan to give you the enzyme kinetics notes and all to discuss those, but already it is 2 hours. So I hope it is too late. But in the next session, if I am conducting, so I will take up this enzyme kinetics in the next class. So these are the important instructions that I wanted to give you, and rest all these are the references that you can follow. And thank you so much for joining. Are there any questions?
Thank you, sir.
Okay, so there is a few more announcement to make. Once you go to the course for this course, the course that you are following, there will be announcement section. In the all the regular information are being posted here itself. So you do check the announcement section regularly. And if you have any question, do join this forum. Okay, there is a Google forum for this particular course. Okay, I will be sending all the recordings and material related to this live interaction, emailing these to all of you. So you must join this forum by just clicking on this ask the question here. Okay, you just click on the ask a question and you will be redirected to the forum website. You join that Google forum and regularly check it. If you have any question, you can paste it there, or you can email me on my email ID. And also there is a feedback form circulated. There is a feedback form circulated at the end of every week. Do fill the feedback form, and if you like this live session, you can leave your comment there. My YouTube channel is this one. You can follow my. You can go to move to my YouTube channel. This is my YouTube channel. I have already shared the link, and you can also check. You can also search it on YouTube as www.youtube.com/winbiocv2022. This is my YouTube channel name. You can find all the playlist, the previous fundamental of protein chemistry course, the assignment problems were also discussed there, and the recordings are also available, and other videos like all the recordings that I will be taking, I will be posting on the this YouTube channel. So you can subscribe this channel, and other updates will also be posted in this channel. Okay. By this, I guess if there are any doubt, I will be happy to take that, or else we can end the session.
Okay, thank you, sir.
Thank you, sir.
Okay. Thank you so much.
Thank you, sir.
Thank you. So all the best, those who are going for examination, GATE examination, and then for your upcoming semester exam also. So all the very best, and do ping me when you have any doubt. Thank you so much.
Thank you, sir.
Thank you, sir.